Okay, so we're driving into the world of carbon nanotubes today.
These things are incredible.
Yeah, at first glance, I was looking at this Wikipedia article you sent over, and I was like, carbon nanotubes? I don't really get it. Like,
Yeah.
tubes of carbon, what's the big deal? But then I started doing a little reading, and
It's wild what they can do.
yeah, it's like
They're talking about using this stuff for everything.
it is unbelievable technology, stronger than steel,
Mm.
lighter than, well, anything really.
Over 100 times stronger than steel, but 6 times lighter.
Yeah,
And we're not just talking incrementally better materials here.
right.
This is like rewriting the rules of what's possible.
And what I think gets me is that it all comes back to carbon.
Exactly.
It's like we were messing around with this stuff back in grade school.
I know, it's mind-blowing.
Yeah,
This isn't some exotic element we've never encountered. It's about taking something as common as the graphite in your pencil
right.
and rearranging its structure at the atomic level.
Yeah.
It's really kind of incredible when you think about it. We're essentially talking about manipulating matter in its most fundamental form.
And so they're talking about these zigzag and armchair patterns.
Yeah.
I'm looking at the article here,
Yeah.
and honestly, that's where I started getting a little lost.
So imagine taking a single sheet of chicken wire,
Okay.
which is similar to a structure called graphene,
Okay.
which is a one-atom thick layer of carbon arranged in a hexagonal pattern.
Okay.
Now, if you roll that chicken wire into a tube, you can do it in a lot of different ways.
Uh-huh.
You can roll it straight at an angle, even with a twist.
Right.
And each of those rolls gives you a different type of nanotube with a unique pattern.
So we're not even just talking about different shapes of tubes. We're talking about the actual arrangement of the carbon atoms themselves.
Exactly.
Right.
And those zigzag and armchair patterns aren't just about looks. They directly affect how electrons can move through the nanotube.
Okay.
This is where it gets really interesting.
Okay. I am hooked. Tell me more.
All right.
So we can basically make these nanotubes conduct electricity or not just by rolling this chicken wire of carbon atoms in different ways.
It's all about how the electrons flow, right?
Yeah.
Based on the nanotube structure.
Uh-huh.
Some arrangements, like that armchair pattern we were talking about,
Yeah.
they let electrons just zip through freely,
Really?
making them excellent conductors.
So they're like tiny wires.
Exactly like tiny wires.
Wow.
But with other patterns like the zigzag,
Yeah.
the electrons hit more resistance, and then the nanotube acts more like a semiconductor.
Okay, and semiconductors are a big deal, right?
Huge deal.
That's what makes all our computers and phones possible.
They're like the gatekeepers of the electronics world,
Right.
controlling that flow of electricity in a really specific way.
Yeah.
And the remarkable thing with carbon nanotubes is that you can have a single material that's capable of acting as both a wire and a transistor
Oh, wow.
just by tweaking its structure.
That's wild.
That kind of versatility you just don't see anywhere else.
So it's like the ultimate building block
Yeah,
for pretty much anything electronic.
absolutely.
But the article did mention some challenges in actually using these things.
Sure.
Something about mass production being a bit tricky.
So imagine you're trying to make a batch of these nanotubes,
Okay.
but instead of getting all uniform structures, you end up with this jumbled mess of different types, some conducting, some semiconducting,
Okay.
and all different shapes and sizes.
Yeah.
It's a bit like having a bowl of spaghetti,
Oh,
where you need every strand to be perfectly straight and the same length.
right. Not ideal.
Not ideal when you're trying to build the next generation of electronics.
So how do you even begin to sort through that and get the specific nanotubes that you need?
Why? Well, that's the million-dollar question, isn't it?
Yeah.
That's one of the big things researchers are working on.
Okay.
They're developing techniques to grow nanotubes with greater precision,
Wow.
and they're exploring ways to sort and separate them by their specific properties.
So like sifting through that bowl of spaghetti
Exactly.
to pick out the perfect strand.
You got it.
It sounds like we're still in the early stages here.
Yeah, we're really just getting started.
But even with those challenges, the potential seems immense.
Oh, absolutely.
I mean, we've talked about electronics, but this article mentions applications in everything from aerospace to medicine.
And that's what makes it so fascinating, right?
Yeah.
It's not just about one thing.
Right.
Carbon nanotubes represent a platform for innovation across countless fields.
Yeah, it's pretty amazing.
And you know what's really interesting?
What's that?
We may not even be the first ones to stumble upon their potential.
Okay, you're really going to have to explain this one.
You got it.
What about us not being the first ones to discover carbon nanotubes?
So you remember that part in the article about Damascus steel?
Oh, yeah, those legendary swords. It's
Yeah.
like from centuries ago.
Renowned for their strength, their sharpness.
Yeah, they were like the stuff of legends.
Yeah.
Ooh, are you saying? Researchers have actually found carbon nanotubes in the structure of Damascus steel.
Get out.
It seems that through a combination of their forging techniques and the materials they used,
Wow.
those ancient swordsmiths were unknowingly incorporating these microscopic structures into their blades.
So they had nanotechnology back then.
In a way, yeah.
And it makes you wonder what they could have achieved
Right.
if they really knew what they were working with.
It really puts it into perspective.
It does.
It's like I was saying, carbon nanotubes are a platform for innovation.
Uh-huh.
We're not just talking about making better versions of existing things.
Yeah.
It's about unlocking possibilities we haven't even dreamed of. So what are we talking about here?
Imagine lighter than air vehicles,
Wow.
ultra-efficient solar panels,
Okay.
self-healing materials.
It's almost too much to wrap your head around.
And we're just getting started.
I know it's like that feeling you get
Yeah.
when you first learned about something completely groundbreaking,
Right.
like electricity or the internet.
It changes everything.
It does.
And it really highlights why basic scientific research is so important.
Absolutely.
It's tempting to just focus on the immediate applications,
Right.
but sometimes those really profound discoveries
Yeah.
come from just exploring the world with a sense of curiosity and wonder.
It's like that saying,
Yeah.
we have a responsibility to be curious.
Exactly.
It makes you wonder what else is out there.
It really does.
What other groundbreaking materials or technologies are just waiting to be discovered?
Right.
Maybe even hidden in plain sight.
Exactly. And who knows?
Yeah.
Maybe the next big breakthrough is just a curious mind and a Wikipedia article away.
Well said. And to our listener out there, we hope this deep dive into the world of carbon nanotubes has left you with a sense of wonder
Absolutely.
about the incredible things happening in the world of science and technology.
And maybe a little bit inspired.
Yeah, because who knows what we'll discover next.